Yes. All right, guys. Shh, we are rolling. So today we're going to talk about function operations. So real quick, as far as math class is concerned, what does the word operation mean? Anybody know? Did you just read that off the board? Yeah, you'd be right. So operations refers to just addition, subtraction, multiplication, and division. So like one of the first things that you guys learned when you first started learning about math probably was how to do number operations. Okay, like my daughter who's in first grade is working on addition and subtraction right now, and she's almost into double digits, getting close. So that's you guys are very, very familiar with number operations, but now we're going to do function operations. So all these equations and things that we've been making, we can do all these operations with all of those. And we've actually done that a little bit in the past as part of different processes for things that we wanted to accomplish. So today we're just going to kind of formalize it a little bit and show you a little bit of notation. So if I want a function that is the addition of two other functions, how do I write that? What does it look like? That sort of thing. So I'm going to just jump right into doing some examples because I think that's probably the easiest way to show you this stuff. So let's say that I have f of x is a function -2 times the fourth root of x. Since we were talking about roots, I figure I'll stick with that to start with here. And then g of x, we'll say, is 18 times the fourth root of x. Okay, so all I'm going to do is I'm going to take these two functions, I'm going to add them, I'm going to subtract them, I'm going to multiply them, and I'm going to divide them. Okay, and just show you how we might simplify that stuff. Also, though, the notation. So if I wanted to add the two functions together and create a new function, the notation for that looks like this. F plus g of x, which basically is f of x plus g of x. It's just taking the two and add them together. So I've got -2 fourth root of x plus 18 fourth root of x. Okay, we talked about this a little bit before. Think about the fourth root of x as just being its own variable. We got some like terms here technically, so I can add these together. So if I have -2 fourth root of x plus 18 fourth root of x, what do I have? 16 fourth root of x. Okay, that's f plus g of x. That's really all there is to it. Okay. Subtraction works very much the same way. Just take those same two, and I'm going to subtract them now instead of add them. So -2 fourth root of x minus 18. It would be -20 fourth root of x. Yeah, good. Nope. All right, so this was f plus g of x. This is f minus g of x. Okay. Now, what if those two functions that I started with, what if they didn't have the same kind of root? Or what if they were just like completely different things? Okay. If I went to add or subtract them together, I wouldn't be able to actually like combine them, right? If this was, say, like if the f of x was a third root of x instead of a fourth root of x, okay, I'd have to kind of just leave it like this first line. I'd be -2 third root of x plus 18 fourth root of x. Not the same thing, so that's as much as I could do. Just put the plus sign in between them and I'm done. But if you can simplify them, you need to. So in this case, because they were the same, I could put those together and then rewrite it in a simpler way. So that's kind of what you're going to be looking at. Sometimes you can simplify it up a little bit. Other times it's just a matter of putting a little plus or minus between the two things and you're done. That's it. So one that you're often going to be able to simplify is the multiplication of two of them. So, and that notation looks like this, f times g of x. All right, so I'll take those two functions and now multiply them together. All right, and we're going to have to use some exponent rules here to help us along to get this done. So multiplying all that together. Okay, so first things first, the negative 2 and the 18 we can go ahead and multiply together. And what's that? Negative 36. Okay. But then I've got this fourth root of x and then another fourth root of x that I need to multiply together. Okay? So, I think somebody just said it. Was it you, Destiny? It's the fourth root of x squared. Is that what you meant to say? Yeah. Okay, so remember when we were multiplying square roots together, I'll just come over here for a second. Think about this kind of thing. Square root of 3 times the square root of 4 would be the square root of 12, right? If you have a square root times a square root, it's a square root. Okay? Fourth root, it's the same thing. A fourth root times a fourth root is a fourth root. Okay? But I'm not doing 3 and 4. I'm doing x and x. So what's x times x? X squared. So it's got to be a fourth root of x squared. Same kind of idea, though. All right, now, here's the thing. That's a little 4 down there. Sorry, it's hard to see. But a fourth root of x squared can be simplified further, though. Okay? Think about our exponent properties that we had before. It'd be just the square root of x. So, if you're having trouble seeing that, I'm going to come over here and try to explain. So, one way of looking at it, when we were doing roots of powers, it was always this number, the power, divided by this number gave us our new exponent. So 2 divided by 4 is 1/2. And what's a 1/2 power, technically? It's a square root. Okay, so that's why this thing would be the square root of x. Now, if you are having a hard time seeing that in your head, think of it this way. A fourth root we talked about is also a 1/4 power, right? So if I have x squared to the 1/4, this is power of a power. I can multiply those two things together. So I've got x to the 2/4. Okay, and 2/4 again is 1/2. And a 1/2 power is a square root. So this is negative 36 square root of x, technically. So that would be the multiplication of the two of them. Okay, so that's multiplying. And then finally, dividing as well. Notation might look something like this, f over g of x. So just take the two things and divide. Now this one actually, if we have like terms like these two are, this one works out really nice. It's really easy. So we got negative 2 fourth root of x over 18 fourth root of x. Exactly. The fourth roots will cancel each other. So what's left over there? Negative 2 over 18. Right. You got it. Yeah, so we can reduce that so it's negative 1/9. Doesn't even have x in it anymore. It's just negative 1/9. Okay? So, yeah, you can do it. If they happen to be like terms, like I said, it's really nice. They just cancel out, and there you go. All right? But the point of all this, though, is just to give you guys a look at how does this actually work if you're adding, subtracting, multiplying, dividing any two functions together. It's the same kind of idea. You just put the two with a plus minus multiply or divide symbol in between them, and then just think about, can I simplify that up at all? Okay, sometimes yes, sometimes no. Go ahead. Then we'd have to leave it again. If they're not the same, they wouldn't cancel, right? So we would have, now in this case, when you're dividing, you can subtract exponents, though. We're going to do one here in just a second, where I'll show you that. But if there's both x to some power, in which case these technically are, you could then subtract exponents and do it that way. So, like, okay, for example, what if we had, we'll do two that are not the same, and I'll show you what happens. So if you have f of x equals 7x to the 5/3, And let's have g of x be 49 x to the 2/3. Okay, so they're similar, but not exactly the same type of thing, right? One's a 5/3, one's a 2/3. Okay, so what's that going to look like? So the f plus g of x for this is one of those where we're just kind of stuck. It's 7x to the 5/3 plus 49x to the 2/3, and that's it. They're not like terms. I can't put them together, so I'm done. Just plus sign in between. Okay. Minus, same thing, right? F minus g of x, 7x to the 5/3 minus 49x to the 2/3. Done. Right? Can't do anything with that. Now, the multiplying and dividing, there's still lots to do with these, though. Like I said, those you tend to always have something to simplify. So let's take a look at what happens with those then. So f times g of x, we're going to have 7x to the 5/3 times 49x to the 2/3. All right, so we got to remember some exponent rules now to help us with this. So what do I do with that 7 and that 49 there then? Do what? Those you actually multiply? Okay. So somebody with a calculator maybe, because I don't want to try and do that in my head. What's 343? Okay. Okay. So the coefficients you multiply. What about those exponents though? 5/3 and 2/3. What do we do with those? Those you add together. Right. So I bet you can do this in your head. What is 5/3 plus 2/3? 7/3. Right? You got 5/3 and then 2/3, 5 plus 2, 7. So 7/3. So this would be 343x to the 7/3. Okay, would be as far as you could simplify that thing. All right, and then the division, what happens when they're not the same? All right, so this one we're going to have 7x to the 5/3 divided by 49x to the 2/3. So in this case, you would divide the coefficients, or just like simplify a fraction essentially, reduce that fraction, and then yes, you subtract the exponents. Okay, so let's try that once real quick. So 7 over 49, that's 1 over 7, right? You reduce that fraction, it's 1 over 7. So we got 1/7, and then we got x. Well, what's 5/3 minus 2/3? 3/3. It would be. Yeah, because 3/3 is what? 1, and x to the 1 is just, well, x. So this thing would simplify all the way to 1/7 x. Okay? So, yeah, things don't cancel out like the last one. However, you still can simplify it, right, by subtracting exponents and doing it that way. So, yeah, that's fine. All right. So one other thing they're going to have you guys doing with this, actually two other things they're going to have you doing with this process. One is they're going to ask you to plug numbers into each of them, which I don't think is too terrible hard. We'll do one like that, but that's one thing. And then also they're going to ask you for some domain stuff. Okay, so let's do one together where we have to, or actually let's talk about domain first, then we'll jump into one last example and we'll be done. Okay. So we chatted just a little bit about domain last week. And we looked at graphs to help us kind of come up with domain. But I want to go back and just think about the way that an equation is written and kind of what we know about what's okay and what's not with particular functions. So domain talks about what numbers are okay to input into this thing. So if I have a square root of x, and again, we're talking real numbers here now. We're not talking imaginary numbers anymore. What numbers can I plug into a square root so that the answer is still a real number? I could plug in a 4, okay. A 6. 8. What? I mean, we could plug in a 100. Anything positive, right? It's only negative numbers that are the problem, right? What? It would be, well, positive, any number that's positive up to infinity. Yeah. Now, technically, there's another number that we can plug in that's not positive, but sometimes gets clumped together with positive numbers. Anybody think about what I'm talking about? No. Pi is a positive number. It's positive 3.14. 0. 0 is not technically positive, but can I take the square root of 0? No. Yes, I can. Square root of 0 is 0. So, because remember, square root's asking you, what number do I multiply with itself and get this as an answer? So the square root of 0, 0 times 0 is 0, right? So that still works. So the only numbers that will work for this, the domain for this, would be x greater than or equal to 0. Does that make sense? Yeah. Those are the numbers that are okay to input into a square root. Okay? All right, well, let's switch it up just a little bit here. What if I had a cube root? So what numbers are okay to plug into a cube root? You can do negatives or positives, right? Everything works. Negative infinity to infinity. Every real number works. So an easier way, well, all real numbers technically, but yeah, you got the right idea. Okay, and that is a symbol for number. It's not a hashtag. All real numbers, okay, would work for that. Because you can take the cube root of a negative, right? Like negative 8 is negative 2 times negative 2 times negative 2. It works. There's an answer to that. So that domain still includes negatives. And positives are still totally fine, right? So everything's good. All right. What about a fourth root? Same thing as a square root. Right. You cannot take a fourth root of something negative, just like you can't take a square root of something negative. Okay. What about a fifth root? All real numbers, yeah. You guys remember kind of sort of talking about this last week? This odd versus even thing? Okay. Do you remember when we talked about even roots? When you're solving an equation using an even root, you have to have the plus or minus. But if it's odd, you don't worry about it. This is related to that, okay? If it's an even root, the domain has to be x greater than or equal to 0. And if it's an odd root, it's all real numbers, okay? So you guys are going to be doing some more of these operations, addition, subtraction, multiplication, division. And when you're done, you're going to have to state what's the domain of it, okay? And you don't need to look at a graph to tell me that, okay? If it involves one of these kinds of roots, if you just kind of follow these rules here, you're going to see that you can just stick with that, okay? So let's do one more example together, and we'll kind of apply that idea. And then we'll also plug some numbers in and do all that. Okay, so we're going to kind of do everything here all in one problem. Okay, and I'll just stick with a couple of roots again. So we'll say f of x is the square root of x, g of x is negative 3 root x. And so our directions will be find f plus g of x, f minus g of x, f g of x, and f over g of x. Okay, that's the first thing. Then find each at x equals 4. And finally, state the domain of each. Okay, so we'll just do each one at a time, and then take care of each one of those bullets for each one of the ones that we do. So f plus g of x. Okay, so bet you can do this in your head even. If I add those two things together, square root of x and negative 3 square root of x, what do I get? Nope. Think of this as 1 square root of x, and I'm going to add to that negative 3 square root of x. Negative 2, right? 1 plus negative 3 is negative 2, so that would be negative 2 square root of x. Okay, so there's the formula for it. Then it says it wants each at x equals 4, so that would be f plus g of 4. Okay, we'll take this new formula you just created and plug in a 4. What is that? It would be negative 2 times 2, right? Negative 4. There you go. Okay. Okay, and then what is the domain of this thing? It's not just square root of x, it's negative 2 square root of x. But that negative 2 doesn't affect what numbers we're allowed to plug in, because it's still the square root little part of it that's creating that issue for the domain of what we can plug in and what we can't. Yeah, exactly. So that's still the same. X greater than or equal to 0. Okay? So that's for the f plus g. Okay? Let's try minus. All right, so what would be the formula for the subtraction of those two? Oh, it's positive 4. My bad. Nope, it's positive 4. Because it's 1 minus negative 3. Should be 1 plus 3. So positive 4. Yeah. Okay, so f minus g of 4 would be 4 times the square root of 4. So what's that going to be then? Be 8. Yep. Okay, and then the domain for that thing? Still got that square root in there. So that's going to be our domain. Okay. Now, when we get to multiplying and dividing, our domain's going to do some... It's going to appear to be some funky stuff, but I will explain what's going on. The first two steps here I think you guys can still do with me without too much trouble. So, fg of x. I'm going to multiply those two things together. So it would be the square root of x multiplied by negative 3 square root of x. What is that going to be? All right, and what's square root of x squared? Just x. So before moving on, I want to be sure. Everybody okay with that? It's just negative 3 times x then? Because we'd have to do a square root of x times the square root of x, and those would cancel off the square roots. So we got that. Okay. All right, fg of 4 should be pretty easy. What does that give us? Negative 12. Good. And here's where things get funny. So, looking at the formula that you came up with for f times g of x, it's negative 3x. What would you say the domain is? It was what?
I have no idea.
No? Negative 3x. What numbers are you allowed to plug into negative 3x? All of them. There's nothing that's going to be a problem there, right? All you got to do is multiply the number by negative 3, and all real numbers you can do that too, and it's fine. So, because there's no more square root, it appears as though the domain should be all real numbers, right? Okay, but it's not. Okay? The reason why it's not is because you need to be able to take the original equation of this thing. So we kind of skipped a step here, but remember, we got this thing by doing the square root of x times negative 3 square root of x. Okay? So our domain should reflect that. It should reflect what numbers can I plug into this, because I got this from this. Okay, that's important. So it's still going to be x greater than or equal to 0, because this has square roots in it. Okay? If I were to plug into this and then get an answer, the numbers should still work out the same. So I got to be careful. Okay? So if you do any simplification, you need to think about domain before you start canceling things off. Okay? That's important. So it's going to be x greater than or equal to 0 for that one as well. All right, so division, same kind of idea. All right? So f over g of x. We divide the two things. So square root of x over negative 3 square root of x. Okay, so what do you notice is going to happen there? Square roots will cancel each other out. So it's negative 1/3. Okay? So what is f over g of 4? This is one of those situations where it's like it's so easy it's hard, or it's so hard it's easy. It's a lot easier than you think. Okay? It would still be negative 1/3, right? If you're trying to take a 4 and plug it into this formula, there's nowhere to plug in a 4. So what's your answer? Same thing, right? It just stays negative 1/3 because there's nothing to change. Okay, so it's not a no solution. It's just that number, whatever it is. Okay? All right, so domain of this one. So go back to before you simplified. What numbers can I plug into this? Okay, so x greater than or equal to 0 again because we have square roots in there. But but when I'm doing division, I have to do one little change to that. Can anybody tell me why I don't do the equal to part there? You can't divide by 0. As soon as we do the f over g, we've got an extra issue in there. You can't divide by 0. That's a no-no. Okay? So if x were exactly 0, wouldn't you be dividing by 0 then in that one? Right? We can't do that either. So we got to stick with the rule for the square root, but on top of that, we also got to make sure that we don't divide by 0. So it's not x greater than or equal to 0. It's just x greater than 0, and then we're safe. Okay? So and that only happens with a division. It's only the division that you have to worry about that. Okay? Otherwise, you can just stick with... You notice how these all came out the same otherwise? Right? All those domains were just the same as the square root one that you had at the beginning. That's true all except for when you divide, because then you have this additional issue of you can't divide by 0. So just be careful of that when you do that. But otherwise, that's pretty much the gist of what you guys are going to be doing today. Okay? It's mostly just coming up with those formulas. The domain is kind of a small part of it, but probably the trickiest, though, I would guess. All right, so your assignment, you guys got some decent time to work on it. So we're going to go 273 to 275, 3 through 19 odd, and then 22. And that's it. It's not a lot, but keep in mind, like each problem you have to do the plus, minus, multiply, divide, so it is a little longer than maybe it seems, but